This is another Roassal presentation. In this case, I will show you the current state and what is the next step for Roassal. So first, who I am Milton Mamani. I'm a software engineer, currently work in France, in Ria, with the Airmot team. So I am from Cochabamba, Bolivia. This is my city. And I start to travel from Bolivia. And then I spent some years in Chile, and now I'm in France. Well, now I'm in Serbia, actually. Okay, so what is Roassal? So simple way is a tool to visualize data. Okay. At the beginning, you started to visualize software systems. It was designed by Alex Bergel. So he creates a profiler, and he needs a simple tool to visualize his data, his results. And in the process, he creates Roassal. And then the last year, he wrote the book, Agile Visualization with Faro, where he teach how to create some visual histories. So many thank you for him, because he gave me an opportunity also to know a Smalltalk community. So how we can visualize data? It's usually we start like that. You have raw data without meaning. So then we need to sort the data. So now we start to do something. We have to arrange the data. And finally, we can explain an history with the data. So that's the main point of any visualization, to tell a history about what is happening. And also, the same data, you see, we can have many presentations of the same view. We can have many different histories about that. So it's very important. So yes, simple demo. Okay, so this is my data. It's not going to be complicated. It's, as you can see, a collection of classes. And now I want to visualize that. In order to visualize, I'm going to use a canvas. And then, as you can see here, I am creating a collection of drawable boxes. Then, very important, I put that boxes in my canvas. So my canvas is a container. And then I use this object that is going to modify the property of my boxes. In this case, it's going to modify the size of my boxes. And also, I can do the same for the color. As you can see, I want to normalize the color from color blue to color red in these boxes. And what is going to be the property for that is going to be the lines of code. The lines of code of this class, because each box, as you can see, has a model. And also, very important, in my domain, in my classes, the lowest, in my domain, in my classes, the lowest class that has the number lines of code is going to be the color blue translucent. And the highest going to be red. And all the intermediate classes are going to be in that direction. And also, here you can see I can create some lines between that. In this case, is going to follow the pattern that I want orthogonal vertical lines and for these boxes, and I'm going to use the superclass for each class. So I'm going to create a line for each box superclass. And then I use a layout. So this layout is also an object that is going to modify the position of my box. So finally, if I see this, I got this. So in this position is collection object, and you can see here there is some other connections. I can zoom in. Yes, I can navigate it a little bit. Okay, so usually when you start to do something like that, it's in a simple script, but then you need to move that in a class. And luckily for me, the class of a class in Smalltalk is class here. So you can create actually a method to define how to visualize that object. So I'm going to use, in this case, the inspector. And the rule for the inspector is that you need to return a presenter for that. So I have here my presenter that is going to draw my canvas. And this object and this visualization method is the same as before, as you can see. I only change, in this case, the collection class to self, because now it's going to be for any class, not only collection class. So, and at the end, yes, I return the canvas, as you can see. Now, if I use this for collection, but in this case, I'm going to use inspected. Yes, I have the same in the inspector for collection. So you see now this is the object collection, but also I have a new tab here. So I can play a little bit with that. And now I inspected another class. This is the sequential collection. I can do the same for another class, maybe this one. Yes. And this visualization, as you can see, is in the context of the subclasses. So this allows me to navigate over my objects and my data domain. So it's very useful when you want to use like that. Okay, so back to the presentation. I would like now to talk a little bit about the new features of the Roassal. So yes, we have export to other formats. So when you create this kind of files, you can export it to PNG, SVG, PDF files, because as you can see, it's a vectorial application. And also, you can export that in videos. So here in this presentation, I have some videos, so you can see how you can export that. We didn't have that before, but yes, we have the SVG import support. So that means that you can have SVG icons, and then you can import it like that in the Roassal canvas. Yes. This is also another, yes?
Can you do some operation on the SVG you involve, or you can just zoom it, scale it in and out?
Okay, the question is if I can do something with my SVG object. The answer is yes, because actually you have all the parts of the SVG are Roassal shapes. Okay? So if you want, yes, you can animate it, you can transform the colors, you can do whatever you want, because it's part of the. Okay, so now I want to talk a little bit about the chart library. We have also chart libraries. So this example you see here, my data is the men and women means, and this data is just the means of the object in 5 days. I can create a specific plot for each group, as you can see, but then I can combine them. I can combine each plot, and for the combination of this plot, I can create a configuration to have this chart, as you can see. And then, yes, I change the title, the padding, and the legend, because, yes, I want to have some legends like that. So it's possible, yes, to have more complicated chart data. This is just an example of how you can write that visualization. Then we have a better support for UML. In this case, this was an experiment what we did with Martin Diaz about iceberg, how to analyze an iceberg commit. So here you can see a commit, and in this area you are see all the classes modified in that commit. Usually you don't change something like that. And also here you can see, for example, the history of the branches of the repository and the photo of who commits in this case. In this area, you can see the classes organized by the class hierarchy. And also you can see in green the new additions and red something that you remove. Okay, this is another one that we prepared. We took a database for a football team. It's a huge database. And we analyzed a little bit this database, and we took this player. And we create a visualization about this player to show the statistics of Lionel Messi. This is a striker currently playing in PSG. And this is another player that we took. As you can see, it has another shape. Yes, this is a goalkeeper. So now if you see, I have here Lionel Messi, I have here Claudio Barro, and this is a new guy. So just by the shape, you can guess what is the player. Indeed, it's another striker, it's Cristiano Ronaldo. So visualization helps us to identify trends in the process. Okay, another example. In this case, I have a dependency matrix. So this visualization is really useful when you want to see dependencies between objects. And this is the package of iceberg. So here you have packages of iceberg. And in this area, you have the top 13 words used in iceberg. And the top 13 are ice and tip. Okay? So they really love to use these words in this project. But also they have name, repository, model. So I don't read a little bit about the iceberg code, but yes, with that I at least understand a little bit what is the intention of this project. And also, yes, someone told me that ice and tip is used in the UI. And yes, as you can see here in the iceberg tooltip UI, they use this a lot. Okay, another visualization. In this case, you can see here a file system visualization. In this case, is the file system from Roassal repository. So yes, all this is the Roassal folder, and you see the inner files in this folder. So the big box is Roassal folder, and the inner boxes like that are Roassal packages. And if you see a box with a color, that means that it's a raw file. That can be text file or can be also a binary file. The size, the area of the box depends on the size of the file. So also here I have a legend. So the legend tells me that I have more than 700 small talk classes. Yes, but also I see here I have two big images, two big files. And if I see the legend, yes, it's a PNG file. So that's why it takes so many space in my repository. Okay, this is another one. In this case, I want to show you a little bit the raw data. It's about flows, working flows. So usually you have a node that is going to have the name, and this is the connection. And in the connection, you can see the source index to the target index, and you can see the value between that connection. This is very useful to plot something like this. This is Sankey visualization, and it's really beautiful, and you can see how the process works. I don't know if you can see the transparency, maybe not, because the display is not so good. Anyway, I have here the oil import, and this goes to oil, and from oil it goes to liquid. And from this area goes to a lot of other subboxes. So this is how you can read it. This is the source, and this is the goal for this visualization. And you can see the flow in this process. Okay, so now I would like to talk about a little bit of layouts. So we have the basic layouts that you can see in my demo. So yes, we have the grid layout. We have horizontal tree layout, the cell layout, and circle layout. Another one that we have is also force-based layout, and yes, Sugiyama layout. But also we have alineations. Here you can see, for example, that I have a lot of text that is contained in boxes. So I can align these boxes in a different way. For example, yes, it can be aligned to the top of the box, to the bottom of the box, to the middle, and then also aligned to the baseline of the text. Roassal is not intended to be used as text editor. We have already some classes for that in Spec and Morphic. So yes, you can use a text element for the visualization. Then, yes, we have the GraphViz layout. So what is GraphViz? It's another project. They have their own web page. So you can download this program, and it's going to, you can use a lot of layouts from them. And really is really beautiful, really useful. So I wanted to connect with them. So I create a bridge between the Faro and Roassal, sorry, from Roassal to GraphViz, and this is the result. Here you can see I have nodes, and it's in force-based layout, so I'm going to use it. Oh, okay. So I transform it to the force-based layout. Now I'm using another Roassal layout. This is the Sugiyama layout. And then I use the GraphViz layout. And as you can see here, even I have the property from GraphViz to calculate the correct position for the line. And this is very useful. And still I can interact with the object. So that's the key aspect, because yes, still I can talk with the object and do some interactions with that. And yes, these are new layouts that I prepared. It's not ready there, but they are going to be really soon. So we have the orthogonal layout, Kamalakawai layout. Well, so many layouts that are going to be part of Roassal soon. So, well, now I would like to talk a little bit about my passion. My passion is animations. I really love animations. So, to define animations is basically from the point A to the point B in a duration, in a certain point, in a certain amount of time. There are two types of animations. There is frame-by-frame animation or interpolated animation. That means that you can draw, like me, a character, and you can animate this character frame by frame, or you can calculate intermediary points to see that. So let's check this video that it was generated in Faro. Yes? You see frame by frame, but yes, I also calculate the position for that. So if you want to use animation, I was talking about that yesterday. You can use the default API like that. So you are going to have an animation with default values. But then also you can define it like that. So you can put the animation delay. You can put from a number to another number and the duration of this animation. And also here in this block, you are going to have the number that is going to be between this, the from value and the to value. Or also you can use a point for that, or even a color. The rule is that you have two objects and you can interpolate between these two objects. And yes, also you have another transformation that is called ESUG. So yes, this ESUG is bounced. So you can see, yes, can do the moonwalk. Another thing that I really like it is the Perlin noise. Was created by Ken Perlin. He used it in a movie, and as you can see, is to create harmonic numbers. So with these harmonic numbers, similar like random number, but not, because you actually put a number in a sequence, and you are going to have another harmonic number between 0 and 1. And with that value, you can actually create stuff, something like that. So I took the Perlin noise, and it's already there in Roassal to create something like that. This is another video created in Faro. And yes. So, well, Roassal is not new. You know that we are here many years. So many users start to use Roassal for a lot of things. So this is a market in my city. We call it La Cancha. And it started as a small market at the beginning. But then many people start to use it, so it grows in a huge way. And now it's really, really hard to be there. You spend a lot of time going to that place, but you can find everything, basically. But yeah, it's a scaling problem. And in the Roassal, yes, we have something like that, because sometimes users start to use Roassal to put a lot of objects. And that creates a time problem for us, especially when we try to find objects, elements in the space, and to draw it in the canvas. So because of that, we changed a little bit the focus of drawing, and now we are focused a little bit in the data structure. So currently, we are using a collection of elements to handle the searching, but that means that we have a linear search for that. And now, if we want to be faster, we have to change to another data structure, in this case, a binary search. So this is the ABL that is going to enable us to have data speed. Basically, it's a binary search. Must be balanced. It's very important to be balanced. If you don't have a tree balanced, you are going to have a linear search. And you can see here how is the process. If you add the number 10 in this data structure, then you are going to have the number 10 in this branch. And if you add the number 14, yes, you are going to have 14 here, but that is going to be unbalanced tree. So we need to do some rotations on this tree. So these are some of the rotations that we can make in these kinds of trees, in the ABL tree. And I use that for my follow trees that I'm going to show you. So this is a quad tree. It's a very convenient tree. So you can put the shapes like that in different positions. And then you are going to divide this area in 4 areas, in 4 quads. Okay? And you repeat the process again and again and again. It's really hard to show you that because, yes, so I'm going to show you a video of that. So this was another video that I created with an image and the quad tree. So you can saw the process of the division. Yes, yes. And yes, we finally have the image. And again with another image. But in this case, I'm going to put a blue color for the empty quads that I have in my quad tree. And yes. Finally, the final answer for me was the rectangle tree. What's the problem with the quad tree? The quad tree does not support overlap. That means that if you have a box here and you have another box on top of that, quad tree doesn't work well. But this guy, rectangle tree, is prepared for that. So here I have my implementation of the rectangle tree. As you can see, I generate a lot of elements. I don't know if you can see, but there are small dots here. That is my visualization for now. We have 1,000 elements. And yes, you can see here now the inspector of the rectangle tree. You can see the objects, but now you can see the rectangle with all the rectangles. And even with this, you can see the first layer. So yes, I would like to stop a little bit in that place. Yes, here. Why we like to stop here? Because if I move the mouse here, now it's really easy for my data structure to know that I am not in this area, right? So I do not search in all my collection, because this big square knows that I already know. I do not have the position of that. So, yeah, let's continue. Yes, the second layer. You can see the third layer, how I divided the tree. And finally, yes, I have for leaf nodes the content. This is another one. It's the same tree, but now you can see what nodes are visiting when I move the mouse over an element. So I visit, in this case, 11 parents. I visit 11 from 1,000. So that's really a speed up in this data structure. And also, I would like to show you that this tree is balanced. So this is the same tree. And you can see here in leaves, this is my content. When in the branches, you can see that I have the square. And all nodes should be balanced. So it's not an unbalanced tree. Finally, I use here metalinks. So you can see here, for example, I have this box with a dot. So you can know how many nodes I visit to know how many objects I have in this square. This is very important because when I have so many elements, I want to zoom out in certain areas to avoid to draw all my nodes. So in this case, for this data structure, I am visiting 41 nodes. Yes. The key aspect is, as you can see, avoid to visit all my collection. That's the key point. I want to visit only the important nodes in that area. And this data structure helps me to do that. This is a real case scenario for the project Polyphemus. They start to visualize memory objects. And they use Roassal to do that. And they have like 100,000 elements in this case. So it's a lot. So the first, when they show me that problem, the image was dying because even moving the mouse over the visualization was killing the image. So we progressed, we changed the data structure, and this is a video of that result. Yes, you can zoom in, yes. Now it's not dying, the events are responding. Yes, still a little bit of laggy, but yeah, it's not something that you can avoid it. So yes, now Roassal is cool. That's the message in this presentation. You can do a lot of things with this, as you can see. You can create user interfaces if you want. There is a group that do that, actually. It's not the intention because, yes, we have a spec for that. So you should use spec in those cases. But in a concrete case, you can do a lot of things with Roassal. This is a little bit the dependency, the current dependency of Roassal. So you can see that we depend on Athens and also in OSU process, well, principal in Athens. But the plan also is that we can move on to another backend. So yeah, there is preparations for years. So if block comes, yes, Roassal should be prepared for that. And yes, and thank you very much for Richard and Pavel that they support the team in Chile. So they are not present here, but yes, without their help and their contribution to the project, I'd probably not be here. To finalize my presentation, I would like to show you a video of 1 minute that shows what you can do with Roassal. Okay, so that was my presentation. Again, I am Milton Mamani from Bolivia. I have a contract with INRIA for 2 years. After that, I'm going to return to Bolivia. So yes, contact me. You have my information there. And that's it. Thank you very much for your patience. Yes. The question is if I work in the zoom factor.
No, the data enrollment of depending, you know, when you have 1,000 objects, you may regroup them to one object, and when you zoom, you exploit the data.
I understand. If I work into clustering the objects and then I can zoom into the objects. Yes, we have something like that. Actually, I prefer that solution because we avoid to try to visualize all the objects. But yes, in some cases it's not possible. Sometimes the users of Roassal, yes, they want to visualize all the objects like that. But yes, I work on that. Actually, it's one of my favorite solutions for the visualization. Yes?
You have this walking girl animation.
Yes.
And so what was the animation done in Roassal only the moving from left to right, or was also the canvases between several steps were generated, or do you have a sequence of canvases or bitmaps for the walking girl, and then you just move it from the left to the right?
Okay, to describe, okay, the question was how was made the animation with the girl walking. So I create actually frame by frame that images with a pen, and then I use Roassal to change the image because we have a bitmap shape in Roassal, and then I interpolate. Oh, the time. Sorry. So I interpolate the position of the shape so you can have the image that the girl is walking. Okay, so that was the process. But if you want, I have the repository of that animation so you can download it and try it in Faro.
So how many bitmaps did you create by hand?
10.
10.
Yes. Yes.
Do you have the stats of Maradona?
Um,
I'm sorry, but I took it personal. You showed Cristiano Ronaldo.
Okay, the question was if I have the stats from another player called Maradona. The answer is no. In that scenario, we took a database of 300 megabytes on size, and it contains statistics of European Soccer League from 2008 to 2016. So no. Yes. Okay, so thank you very much.